Howdy once again, it's Tubalcain, and the title of this video is Knurling on the Lathe. And you may have noticed that knurling has been conspicuously avoided in all of my videos because in fact it's a difficult thing to do, especially was it difficult for high school students to master, and often that would be the last operation they would do on a project, and it wouldn't turn out very well. They'd have cross knurls and just knurls that didn't look good, or they would bend the work because there's an awful lot of pressure against the work. So I tended to even avoid it in the school shop. But what is a knurl? Well, a knurl is a crisscross pattern, or it can be a straight knurl like this, that is used on tools and many other devices to allow a better grip, or to improve the appearance, and in some cases for repair, such as pistons where we're increasing the size of them, because in fact knurling is a process that is by and large displacing the metal rather than removing it, so it does enlarge the diameter slightly. Now there is some metal cutting because you're going to see swarf in the oil, so there isn't any doubt that it isn't removing some metal, but mainly it's displacing or embossing the metal. Most knurls are done on turret lathes because it works every time, and that's really what I'm going to show you in this video, a turret lathe type of tool. I'm not going to show you the traditional one, although I will talk about it real briefly. But here on this 100-year-old micrometer you can see a straight knurl that gave you a better grip, and I think that's made of German silver. Here on this imported one you're going to see that it's a straight knurl, and you got a knurl here and here, and on this Starrett micrometer we've got a diamond knurl here, and then even over here on the lock. So the Starrett company and Brown and Sharp, you can see, made an awful lot of knurls. And then on dial indicators you're typically going to see knurls. We got one here on this set screw, and we got one to aid the grip on the dial itself, and even a little bit of a knurl here on the plunger. You're also going to see knurls that are imitation knurls, I'm going to call them, because they're actually molded rather than cut. Now they would have knurled the mold, I guess you could say. And here we got a knurl, and we got a knurl right here as well as here, and that's all plastic, so I'm not really going to talk about that, other than you see these knurls just all the time, and you probably don't even think about them. You have seen me use in my videos from time to time this hand knurler. In fact, this one is called a knurl master, and it's used something like a pipe cutter. The handle goes on over here, and you just turn it around, and you're using this in the vise, not in a machine. And I have an extra set of rollers here that are straight rollers. These are the type that gives a diamond pattern. No doubt the knurlers you're most familiar with are the Armstrong or Williams type that are a traditional tool holder like this, and really I don't like these at all. But in this 50-year-old catalog here you can see that there are several different types, and I do have one of these. In fact, this is a Craftsman, but it probably is made by one of the big companies. They didn't make anything themselves. But down here you can see that you can buy replacement rollers in coarse, medium, and fine in the diamond pattern, as well as in the straight line pattern. And in fact I have here several different brand new sets of rollers, and you can buy these any place. I like the kind that has the chamfer on here, but you're going to see some that does not have a chamfer at all. But this type of head allows this to self-center. And on the turret type here you really have, as you rotate it, you got fine, medium, and coarse knurls. These are difficult to use. They're very prone to error. They put tremendous pressure on the cross feed screw and nut, and I think cause damage and wear to those parts. And your work has to be supported very well, because there's just such pressure against the work that it causes the work to flex. So you have to hold the work between centers, or if it's small work, it's not going to work at all. It's just going to flex. And it's larger work, larger diameter work that doesn't flex tends to work a little bit better on the lathe, but you need to work near the chuck where the support is the greatest. I'm not going to use this now, and I know this is the kind that you people have, and some of you are probably saying, oh, he's not going to do what I wanted to see, so oh well. I'm sure that many of you have this type of knurler, and that fits the standard Aloris type of tool holder or tool post, but in fact it doesn't function any differently than this. So I'm not satisfied with these either. But I used to have an Aloris, and this is a picture of an Aloris. It's a pinch type, and it really was wonderful, but you need a second mortgage to buy one. In fact, I sold mine, and I lament that, and no longer have it, and with the proceeds was able to pay off my house, and that's how much those cost. Many companies make this type of pinch knurler, and again, this is an Aloris product, but it fits into a tool holder rather than being a portion of the tool holder. And again, it pinches. And some of the other companies make some that they call a scissors type, and in fact I wish I had one. That's the kind that I would prefer if I were to buy one. But I do not do knurling that often, so I didn't want to invest the money in it. But consider that type and a high quality one if you can. And I have seen plans to build these, or make one in your own shop using rollers that you buy, so you might consider that. I'm not sure if I just mentioned it or not, but sometimes knurling is done internally in large bores, but that is usually also a hand process, but with a device that expands within the hole, and you can look pictures of that up and on the internet, and you're going to find them if you're interested in that. This is a page out of the South Bend How to Run a Lathe book, and it tells you how to knurl and what knurls are and so on. So look that up, read that, but in fact they only devote one page to that, and I think that's very disappointing considering how difficult it is to do knurling and do it properly. The Atlas book devotes 2 pages to it. So if you have that book, look that over. And they're going to tell you to run it at very slow speeds and to support the work, and some of the things that I have already told you, and that you need a lot of lubricant, and the lubricant helps wash the swarf away, as well as aid in the actual cutting process. And do not try this with hardened steel. But here's the second page of knurling. But neither one of the books devote very much information to it. They just gloss over it. I would hazard a guess that 98% of all knurls that you see on manufactured products are done on turret lathes. And in fact, this is the 1942 Brown & Sharpe catalog, and there is an adjustable knurl holder in 3 models and a different kind down here. And notice that the price was $23.50 then in 1942, so imagine since a dollar's only worth a dime or 20 cents now, that's hundreds of dollars for one of those. And in fact, I did buy this one, just like the one in the catalog. I bought that from my buddies in Leland, Illinois, at the screw machine shop. And if you haven't watched this video, make sure that you do, because I'll take you through that shop, or I did take you through that shop, and that's where I bought that. And that was a video that had over 50,000 people took that tour with me, so make sure that you look at that video if you haven't seen it. And many people are like me and lament the passing of the screw machine shops. So, well, I'm getting off subject there, but this is a Brown & Sharpe knurler that is to be used in a turret lathe, but in fact I'm going to set it up here in a few minutes on my Clausing Lathe and run a couple knurls for you. This is a Brown & Sharp, it looks like 20D knurler, and notice how heavily it's made. And this is really meant to be held in the turret, and that's I believe 3/4 of an inch. Now it uses replaceable rollers that can be set in there either straight or at different angles, and you can even see here a little protractor on the end. Also, the depth of the rollers can be changed from each direction to accommodate different sizes within the range of this tool. But in fact it is set from that shop for 3/8 stock, so that's what I'm going to run. I'm not going to change the adjustment on it, but these are these work every time. With a flood coolant, you're not going to say, oh please, I hope this knurl turns out and that it's successful, because they will turn out. Now keep the rollers clean. I'm going to blow those off before I put it back in the lathe, and then I'm going to show you how I set it up. And it has to be set perfectly parallel with the bed or the ways in this direction, and centered height-wise. Probably when you set something up like this, you're going to need to run several pieces and trial and error until you get it just so you get the kind of knurl that you want. You probably can buy one of these reasonably priced on the internet, since these aren't used anymore, and there's probably a lot of them available. So, and I think my buddies up in Leland still have some, but I think you're going to be impressed when you see me use this. Now, on screw machines, they did this knurling quite fast. That is, they did it with a rather fast spindle speed, and they fed it rather fast. Whereas with the hand knurlers, we were always taught to go back gear, slow speed, and feed it slowly and all of that. But this is a very quick operation in comparison. So let me show you how I'm going to put it into the Clausing Lathe. This is a Dorian tool holder. It'll fit the Allures tool post or the imports. But the thing you're going to notice about this particular one, and this would be expensive also, but it's a lot wider here. It's going to accommodate larger tools than most of what you're going to see in the common sizes. And this is a B size. It fits a BXA, and I'm going to put this in just like this. I'm going to shorten it up as much as I can, and I'm going to tighten down these screws, just 2 of them, and I would like to put it in there not like this, although that would work, but you can't see what you're doing, so I'm going to put it in like this. Tighten these 2 down, and for this operation I like to square my tool post up with the chuck, and the way I like to do it is to just bring this tool holder up against the face of the chuck, and I'm straddling the jaws. Get it in there so it's touching, and you can tighten down the tool post. So I'm talking now about right in here. Next, the Brown & Sharp knurler is going to go right into the holder, like this, and I'm holding it in up against the back of the tool holder here so that it is not crooked or at an angle, and then I'll tighten these up real well. I want to set the knurler on center, the same as we would set any lathe tool on center. That is, I'm talking about this height adjustment here. So in order to do that, The hole or the bore in this happens to be 3/8, so I'm taking a 3/8 drill bit. You could use a transfer punch or make up a piece or whatever you want to do, but you can see here I've got the point of the drill bit facing outboard, and if I bring my tailstock center in like that, now I can raise and lower this, and I'm just going to eyeball it until I get it right on center, and then tighten and take the drill out of there. I get a lot of comments about the level of detail that I give, and favorable comments, so I will continue to do that, because I know that there's some videos that just say go to work, boys. And so anyway, in this close-up here, one thing that I didn't mention is that this type of knurler allows you to make very long knurls as well. Can you see the end of the work out here? And in fact, when this is mounted in a turret lathe, the work can be as long as desired within the limits of that machine and how deep the turret allows the stock to travel. And that's why they put a hole all the way through these knurlers like that. So the next thing I'm doing here before I knurl is, and if I can close this up just a little bit here, and this is an undersized piece. This is 5/16 stock, and in fact I'm going to knurl 3/8, but I put a smaller one in there on purpose so that you can see that I can set the cross slide here so I'm exactly halfway between the two. In other words, I've centered it here in this axis. And then I'm going to try to avoid touching that crossfeed knob, and I'll zero it out so I can return to that should I have to. So we're just about ready to make the knurl. Finally, I'm ready to knurl, and a couple things now. I've got a rag down underneath to catch some of the mess, because I have to use a lot of oil. Do not use a brush. It'll just pull it out instantly and it'll run it through there. So use a squirt oil can of some kind. And I'm just using cutting oil. And my RPM is around 200, and I'm going to feed it longitudinally at about a feed rate of 22 thousandths. And you can do this by hand too, but I'm going to use an automatic feed and squirt plenty of oil on there. And this is aluminum 3/8. And it'll be a diamond knurl, so let's give her a try. And I did chamfer the end a little bit to get us started. Let's see what it looks like. I'll clean it up a little bit. A couple things. First of all, notice that it does produce swarf, even though we are basically embossing. And I got a nice crisp diamond knurl pattern. And I did run a toothbrush and some solvent over this just to clean it up. So that's it in aluminum. Let's try it in steel. Next, I'll give it a try in cold rolled steel, and I'm using the same RPM and feed rate and oil. Alright, there's the cold rolled steel. Nice sharp diamond pattern. Looking pretty good. And just for the heck of it, I put it on the micrometer, and you can see that the 375 thousandths diameter has been increased to 390. So it went up about 15 thousandths in diameter, and you can see why sometimes people knurl something so they get a better press fit or whatever the reason. But generally we use a straight knurl for that, but I guess that's a matter of preference or opinion. And now, since I'm having fun, I think I'm going to run a straight knurl. Well, I know I'm going to. Notice that I readjusted the knurlers so that they are at 0 degrees. In other words, they're straight across, and we're back to aluminum and 200 RPM, and nothing else has changed. So let's run it in there. I've chamfered the work just a little bit. Is that showing up all right? It's amazing, Grace. Nice straight knurl. Just for variety, I'm going to run it at a higher speed, so I'm back in direct drive 360 RPM here on the Clausing 12-inch. Also, have you noticed that it doesn't really matter how much work is extending from the chuck, because I don't have to worry about it flexing or in any way moving. The work is rigid, and I'm going to feed it by hand now rather than using power feed, just for a double whammy here. So let's give it a try. And it looks like pretty good results with direct drive as well. I'll show you a close-up of that in a minute. But I think I remember when I ran turret lathes years ago that we didn't change the speed, although some of these turret lathes had 2-speed motors, and sometimes we changed the speed for different operations. But I think with aluminum, it cut just fine at that higher speed, and I do not intend to do it with steel. But let's go over to the bench and take a look at some of these samples now. Now for a little close-up on these finished knurls, and I'm just about done talking here, but these are the 2 pieces of steel. Notice the formation here of the diamond pattern, and it is nice to have a knurl end up in a shoulder, not a shoulder, but an undercut or something like that, so you don't see this the way the knurl ends. But you're not going to notice that at the beginning when we start with a chamfer. Now on the aluminum ones, again, there's the diamond pattern. Those still need a little cleaning up. And here's the straight. I should have brushed that one. And the next one here is the one that I did at real high speed, the very last one with the black mark on it. So it didn't seem to make any difference on the aluminum whether it was at well, it was 360 for the high speed and 200 about, or a little less for the low speed. And remember, I also fed this one by hand, and I do remember on the turret lathes that we were feeding the turret, although there was a power feed on the turret too, but I remember feeding them because they were long knurls, and I made 100,000 of them out of stainless steel because they were shafts for fishing motors, and they pressed the laminations onto the knurl. So that's what that, and they were straight knurls. And that's a long time ago. That about concludes this video on knurling, or knurling as the kids would say. I hope you enjoyed it and learned something by this. And I recommend you throw these away or sell them onto eBay to some unsuspecting sucker and get yourself one or more of these. And you could also mount this in the tailstock where the drill normally goes, the drill chuck. You have to make an adapter of some kind. This is hardened steel, so you're not going to be able to turn that down, but it would work that way too, and it would be centered right away for you without fiddling around like I showed you earlier in this video. So, gentlemen and ladies, and there's always a few ladies watching, this is Tubalcain saying so long for now. Be sure and watch my 600 other videos, and I'll see you in my next shop video.